Hello my dear students, how are you all? Welcome to Deeksha Karnataka YouTube channel. I hope all of you are doing good. So today I'm here with top 30 MCQs from the chapter LPP and probability. Yes, so not many questions are coming from this chapter. Basically 1 to 2 questions you can expect every year. Okay, so from LPP you can expect 1 or 2 questions. Same goes with probability as well. 1 to 2 questions from this chapter. For again PU2 portions, these two chapters are from. So we'll solve the questions top 30 MCQs, which can be again your PYQs are there. I've taken LPP mostly PYQs, but in probability I've taken mix of both. I've taken PYQs as well as your questions from which is relatively to ready for KCET examination. Okay, so let's solve the first question that we have. So if you have a look, question number 1, if x plus y is less than equal to 2 and x is greater than 0, y greater than 0, again these are non-negative constraints, the point at which maximum value of the function will exist. They've given the points already. Okay, so we'll just we don't need to find anything else, just look at the function and look for the values. So what we can get, bacha, we can see here, of course 0 to no, 2 0 yes, 2 0 yes. Please check. How come, sir? If you want you can draw the graph also. Graph will be 0, 2 over here, and 2, 0 is over here, right? TF less than, it means this is my feasible region. Okay, so these 2 points are the, again one more corner point is there, 0, 0. So total of 3 corner points are there, 0, 0, 2, 0 and 0, 2. Okay, from here you can see the maxima, the function z attains the maximum value as 6 at the point 2, 0. 3 to the 6 and 2 times 0 will be 0. Answer is C, sir. Okay, so this is clear. Alright, let's move on now. So before moving on to the next question, I have a announcement, a request to make from all of you who are somebody, if you're somebody who is very serious for the examination and looking to solve more type of questions, especially in chemistry, physics and maths, of course in biology as well, then you should get this test series right now, Abhyas KCET test series. Okay, available at a price of $14.98. A lot of students have already enrolled. If you are looking to really practice the questions, different variety of questions, again in the part test, in the full length test, part test means syllabus wise you'll have test given in subject wise, syllabus and subject will be given to you. Accordingly you can take the test. Okay, so if you're somebody who is looking for something like that, looking for a test series of that up to the best quality available in the market right now, please choose Abhyas KCET test series for sure. Okay, so 35 total tests are given in this, including the part test and full length test across all the 4 subjects, PCMB, as I said. So test is already live. A lot of students have already involved and already taking the test. If you're somebody starting today, it's okay. Take the test today and start from the paper that is coming for this week. Whenever you can find the time, you can take the papers that have already been conducted or given to you in the platform. Okay, so again our test series will be if you want to make the purchase, you have to access the platform that is given from our side, and all the papers will be live on the platform itself, not on YouTube. Okay, so let's start with the question number 2. Chaliye, if an LPP admits optimal solution at 2 consecutive vertices of a, okay, basically they're talking about 2 corner points, right? 2 corner points, am I right? So we are talking about the optimal solution is occurring at 2 corner points. It means, let's say I have a line like this now. So this is the point. Okay, so all the point on this line joining the 2 optimal solution point will be your point of maxima or minima, whichever it is this case, right? They have given only optimal. It can be either maxima or minima, right? It can be maxima or minima as well. So all the points on this line will be your optimal solution. Okay, so basically the optimal solution occurs at every point on the line joining these 2 points, these 2 corner points. Option B is correct. Okay, very important. I think all of you know this already. Question number 3 now. Chaliye. For the LPP, maximize z equals to x plus 4y subject to the constraints given like this. Let's solve it. Let us solve this. If you check this out, what do we have? We have we'll just try this out. X plus 2y, when x is 0, y is 1, right? Y is 1. So 0, 1 will have, when y is 0, x is 2. X is 2, y is 0. Correct now? Put it here. X 0, y is 1, y 0, x will be 2. Same way, when x is 0, y is 4. When x is 0, please check. This is less than, right? Okay. When x is 0, y is 4 from here. 2y goes to 8, right? So y is 4 somewhere over here, 0, 4. And when y is 0, x is again 8, so. Okay. So 8, 0 we have. These are Parallel lines, right? Yeah, they are parallel lines, of course. They're saying more than, right? It means this side. So do we have any feasible solution for this, bacha? No, we don't have, because this is giving me below, this is giving me above. Okay, means there's no intersection of these two constraints. Of course, has no feasible solution. Has no feasible solution. You don't have to draw it, just wanted to explain you, that's what I've taken. Otherwise, check the parallel lines and check the sign of the inequality. Less than here, greater than here, that is more than enough to identify the result. Okay, because from this one you get this is the feasible reason. From here you get this was the feasible reason, which is now there's no reason which both these inequalities are defined, okay, or which satisfied. So that's why no feasible solution. 3 is done. 4th now. The feasible reason of LPP is shown over here. I hope this is clear, right? So if not, I'll just shade it. This is the feasible reason, okay? Shall now clear? Okay. So they are looking for minimum value of z. Minimum value of z. So let's just cross check. At z equals, what is it given as? Z is given as 3x plus 9y. If I take 0, 10, 90, okay. If I take 0, 10, 90, 0, 20, then of course 180 we have. At 5 will become 15 at this point. It will become 15 plus 45, na? So 60. So far minimum, and about 115. Okay, this will also be a very big value, right? Actually maxima, correct, na? Yeah. So your answer is going to be what, sir? 60. Looking for minimum value is 60. The point they are looking for, so point A is the correct answer. Point is 5, 5. So the minimum of this objective function z exists at the point 5, 5. Okay, chaliye. 4th is done. Okay, question number 5 now. The feasible region of a LPP is shown in the figure. Z equals to 11x plus 7y. Objective function is given to you, 11x plus 7y. The maximum value of z occurs at. So we'll look for the point of intersection first. So look at this graph. Over here we have x plus y equal to 5. So this point, bacha, is nothing but 5, 0, right? This point is 5, 0. Agreed. And this point is 0, 5. All right. What about this? We'll have when x is 0, y is going to be 3, right? 0, 3. And this point will be, sir, 9, 0. My constraint, this is my feasible reason, please check. That's my feasible reason. Okay. So we have to look for a point of intersection over here. Please check. X plus y is 5. Okay, 3, 2. How comes up? 3 plus 2 is 5 here, and 3 plus 2 into 3, which is 6, will be 9, of course. Okay, it means 3, 2 is the point which satisfies both the lines. Okay, so I have 3 coordinate points now, 0, 5, 0, 3, and 3, 2. I'm looking for maximum value. Please check. Maximum value I'm looking for. Okay, so at this point I'll have, sir, 3 into 11 is 33 plus 14, right? So we have 47. We have 47 at this point. What about this? So we'll have at this point 35, na? And over here I'll have, please check, 21. So this is my clearly maxima value. 47 is my clearly maxima value. Hence option C is correct. Option C is correct for 5th one. The maxima occurs at 3, 2. 3, 2. Okay. 5 is done. Coordinate points of the feasible region determined by a system of linear constraints. They have not given the constraint, they have given us the coordinate point itself. Okay, is 0, 3, 1, 1, and 3, 0. They have given the constraint to us. Great. They have also given the objective function z equals to px plus qy. All right, where p and q is both positive. Condition on p and q so that minimum of z occurs. Okay, we have minima at these two coordinate points. Please check. 3, 0 and 1, 1. So we're going to put the value basically in the z as z minima equals to, please check here, if I put 3, 0, I'll have 3p plus 0, x is 3, y is 0. One more time I can do the same thing. When I take this constraint 1, 1, I'll have, bacha, actually not 3. I'll have here p plus q. They both will be equal only, no? So 3p equals to p plus q. I get 2p equals to q, hence p equals to q by 2. P equals to q by 2. Option is A. Please check. Option is A. Alright, so you can see the questions trend as well, understand the properties and the question which is asked in your examinations, okay, PYQs. That's how you get to know what you can expect this year as well, okay. So you can see the trend in the PYQs of LPP. Same thing we'll do with your chapter in probability as well, okay. So let's have a look. This is my feasible reason given to us. Now this is clearly visible now, okay. The stated region in the solution of sets of which of the following inequalities, basically they are asking us the constraint in this case, okay. So to identify from here, so let's look at this line, bacha. When x is 0, when x is 0, y is 5, okay, and when y is 0, x is 4. That is not possible. X is 0, please check, y is 5, no? So I can write here 20, of course. X is 0 means I can write here 4y. Okay, 5x plus 4y looks good. Yeah, x is 0, y is 20, and y is 0, x is 4. Correct. This is my line. I'm looking for on this side now. It means inequality will be more than. Will be more than 20. Please check. Will be more than 20. Okay. So that's my inequality. What next, sir? Have a look. Now we have, sir. We have. X is equal to 6. On this side I want. So x is less than equal to 6. Correct, right? And y equal to 3 I want y less than only because below. So less than equal to 3. Please check. So which option is suitable now? I think option number C looks good. X less than 6, y less than 3. Yeah. Option C is correct. Please check. First constraint is over here, second constraint is over there, and third one is over here. So we have all the three constraints known now. Moving on to question number 8. The corner points of the feasible region of an LPP are, okay, they've given the corner points 0, 2, 3, 0, 6, 0, 6, 8 and 0, 5. Then the minimum value of, okay, this is not 2, sir. This is actually Z, okay. This actually is Z over here, okay. So basically they've given the objective function as Z equals to 4x plus 6y. All right, looking for point of minima, okay. So let's find this. We have all the corner points, right? What is there? We have 0, 2, we have 3, 0, 6, 0, 6, 8 and 0, 5. Let's identify this Z value on these points. 0, 2 means 4, 0, 6 to the 12. I get 12 over here. 3, 0 means 4, 0, 12 and again 0. So 12 I get one more time. 6 for 24 I get on this side. Something again bigger will be coming over here. Excuse me, I dropped my pen. Yeah, something bigger will be coming over here. And 0, 5. So I'll have 30 now. I'll have 30 over here. Okay. So please check. There are 2 points of Z minima. It means wherever these 2 points are there, no, 0, 2, 3, 0, 0, 2 and 3, 0. On the line joining these 2 points, bacha will have every point as point of minima only, right? Correct? So we have infinite number of points as the point of minima. How many points are there, bacha? We have infinite number of points. This point is going to be 0, 2. This is going to be 3, 0. So both points are having the same value of Z minima as 12. It means the point consisting on all this, on this line, every point will be point of minima only. That's why answer is C. 9th now. So we have now the shaded region in the figure given is the solution of which of the inequations, okay. Okay, again you have to look for the inequality only. Please check. I hope the reason is clear to you. This is the feasible reason. Okay, chaliye. Let's move on to find the optimal solution. Okay, that is also not required. We are looking for inequalities which is true. So for this condition, this line we are looking for greater than, right? And for this line, okay, first of all we can identify this line, right? This is easy to find. X plus y. This line is, bacha, please check. 7. If you want less than, so x plus y is going to be less than equal to 7. This is clear to find, okay? So we have only 2 such options, B and C. Alright, now if you check here, the condition is going to be, they've given the equation already to us, 2x minus 3y plus 6. Okay, since the y is bacha negative over here, no, we have to take equal to sign, greater than sign. Think about this. Yes, I'm looking for below this point. Great. Equation is going to be, please check here, 2x minus 3y plus 6. Okay, for that reason I have to take the greater than sign because y is negative over here. Okay, means it will move on that side, no, it will become less than only, right? So basically I'll have for this condition I'll have, check here, 2x minus 3y plus 6 greater than equal to 0 will be there. Are we getting it? Sir, why we are looking for below, sir? We're looking for below, then y greater than, we should usually take less than, no? But y is negative. If you move this y on this side, no, it will become positive only, right? Hence y will be less than. Okay, so we're looking for greater than symbol. Hence option C is correct, sir. No, option B is correct, sir. Greater than I said, no? Greater than. Option B is the right option. Please check. Yeah, 9th option B is correct. Have a look. So option A, so we have only 2 cases of less than equal to sign. So B and C are the right choice to make from, and option B is correct because we have greater than symbol over here and they want only greater than symbol. Okay, chaliye. So again the last two are non-negative constraint, which is x greater than 0, y greater than 0 for the first quadrant. Alright, now question number 10. So we have now probability. Let's solve this. These are again, so we have solved the first 9 questions as the PYQs from LPP, but now we're going to solve questions of a probability which is not a PYQ but very good questions. Okay, so I'll take questions on total probability, questions on your normal probability, okay, where we're talking about independent events as well. Okay, and of course we'll solve questions on your conditional probability and Bayes theorem. Okay, so let's check all of them, and after this questions comes your PYQs. Okay, so a coin is tossed thrice and all the 8 outcomes are assumed equally likely. Great, of course, means unbiased condition is there. If E and F are events such that E, the first throw results in head. So we know total of, if you toss 3 coins, bacha, if you toss 3 coins, we have total of 8 possible outcomes. Please check. 2 power 3 is there, na? So total of, I have 8 outcomes possible. That's okay. Great. And what are those outcomes? So I don't have to write all those outcomes. We are looking for just event E and F. So let's write for the event E. Event E says the first throw results in the head. So HHH will have this, will have also as HHT, will also have this as HTT, and we have this as HTH also. Correct, na? So only in these 4 cases we have first outcome as heads. Okay, otherwise then what will happen? The first will come as tails. Okay, so please check. Looking for the event F now. What is event F? The last throw results in tail. Last is tail. So I can write here, please check, tail, tail, tail. Next I'll have THT. I have HTT, and please check anything else. TTT, THT, and HHT, of course. So in these cases we have last outcome as tails. Tail, 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 tail. Okay. Now what I'm looking for? So let's find the value of the probability first. So okay, before that we have to look for intersection. Okay. So intersection, which for this you get here HHT is there. HHT is there. This is common, no? HHT. Please check. And we have one more thing common. HTT also is common. HTT is also common. Please check. Anything else is common, sir? Of course not. Okay, so E and F will have HHT, and what else we have? HTT. HTT is common, sir. HHT and HTT is common. Basically, so if I'm looking for this answer, I'll have 2 by 8. Why 8, sir? Total is 8. That's why. Total is 8. Okay, so basically answer is going to be 1 by 4. Okay, so let's look for P now. P will be, sir, 4 out of 8. Please check here. E is what? 1, 2, 3, 4. So 4 out of 8. How much is that? 1 by 2. PF, sir, again same thing. 1, 2, 3, 4. So again 4 out of 8. So 1 by 2. PE intersection F is, bacha, 1 by 4. So option B is correct now. Please check. Option B is correct. The independent property is true over here. If you multiply these two, what are you going to get? Please check. You're going to get this as, excuse me, you're going to get this as 1 by 2 times of, so 1 by 4. And this is same as this. Hence, they are equal, right? Hence, they are equal. So your answer will be option B is correct. Okay. Option B is the correct option. Question number 11 now. Two cards are drawn from a well shuffled deck of 52 playing cards with replacement. Of course, very important word. Means you have to put back the card that I've taken. I've withdrawn a card and then I have to put it back. There's a choice of given replacement to us. So we have to put it back. Okay. Probability that both cards are aces. Aces in both the cards. Okay. So I want a and condition. Now. First is ace and second is ace. Okay. There is no optional condition. They are saying both. It means we have to take the intersection, of course. Okay. So please check here. I'll have 4 by 52 into 4 by 52. So 13. What is the answer? 1 upon 13 into 13, right? So 1 upon 169. Option is A. Please check. Option is A. Got it? Very simple question. 11th is done. 12th now. Given that the event A and B are such that PA is 1 by 2, P and B is P of A and B. They've given this value as 3 by 5. PB they have also given as P. Okay. Probably that of B if. Okay, we have two cases over here. Case 1 is when they are mutually exclusive events, and case 2 is when they are independent events. They are both different things. Okay. Exclusive means please check is 0. They are having nothing common. That's why PA intersection B will be equal to 0. So from here what I get, please check. So I have this formula PA plus PB plus PA intersection B equals to 3 by 5. Have a look. This is 0. So I get from here PA is how much, sir? 1 by 2. PB is how much, sir? P. 3 by 5, I'm looking for the value of P only, right? So 3 by 5 minus 1 by 2 LCM will be, please check, 10. 5 2s are, so 3 2s are 6. 2 5s are, so 1 5s are 5. I get 1 by 10. I get 1 by 10. So if there's only one option like that, option D has to be correct. If you want, you can solve it for the second case also. But from here you can see the option. If you want to get the answer from here, option D is the right answer. Okay. But let's look for the other case also, independent event. For this we have PA into PB equals to P intersection B. So we can write this statement one more time as PA plus PB plus, sorry, not plus, I wrote plus here, no, it should be minus actually, excuse me, minus PA intersection B will become this bacha, PA into PB equals to 3 by 5, right? Okay, so we have the values now. We have 1 by 2 for this. This is P, and this is, sir, again 1 by 2 times of P. 3 by 5 I have. Please check, I can move this 1 by 2 on this side. I get same thing. P minus 1 by 2 P is nothing but 1 by 2 P. From these two we get what? P minus half of P is how much, sir? Half of P. So 1 by 2 P for this case. 3 by 5 minus what I have? 1 by 2. What I get? Please check. So for this I get this as 1 by 10 only now. So I get P equals to 1 by 5. 2 and 10 will cancel, right? 5 times. Option you can check here. 1 by 10 and 1 by 5 is the answer. Okay. For the value of P. What is P, sir? P is the probability of the event B. Okay. So both the cases are given here, mutually exclusive and independent events. This is for independent events. Case 2 and this is case 1 for mutually exclusive events. Have a look. Okay. Question number 12 is done. 13 now. 2/3 of the students in a class are boys. Okay. So if I'm choosing one boy, what are the chances of choosing? Let's say if I'm choosing one student, chances of me choosing one student will be, which is boy, will be 2 by 3. If I have to select randomly one student in a class, okay, unbiasedly, and so since they've given the classification as 2/3 is boy, it means for me the chances of picking a boy will be 2 by 3. I don't know whether it is boy or not. If I'm choosing one student, it will come out to be boy. Chances is 2 by 3. Again, rest are girls means PG is 1 by 3. Okay. It is known that probability of a girl getting a first class is 0.25 or 1/4, and that a boy getting a first class is 0.28. Find the probability that a student chosen at random, basically, let's say I call the event A for a student to get first class, marks. Okay, so I get PA basically will be equal to, please check, first class student from the boys category. So P, all the boys who's getting so first class from the boys category. So from the boys category into probability of getting the boys, okay, and plus we'll have first class from the girls category who are getting times of, please check, first class from the boys and first class from the girls. So PAB times PB and PAG times of PG. How we write this, sir? From the statement of, please remember this, total probability, sir. From where we remember, sir? From the denominator of Bayes theorem. This is the definition of total probability, and that we write in the case of Bayes theorem every time in the denominator. Please check. Okay, so this will become, have a look. I'll have this as, this is given from the boys category. We have 0.28 is given. So 0.28, and boys is going to be 2 by 3. Plus I have PAG as 0.25 and 1 by 3. Okay, so take the LCM now. LCM is 3, sir. So 2 into okay, it becomes 0.56. Over here I'll have 0.25. So you can add this. You'll have this result as 6 plus 5 is 1, and 5 plus 2 is 7, carry 1 is 8.81 by 3, hence 0.27 is the answer. Hence 0.27 is the answer. C is correct. C is correct. 13, option C is correct. Moving on to question number 14 now. A purse contains 2 silver and 4 copper coins. Okay, a second purse, let's call the purse to be purse A and purse B. In purse A I have 2 silver and 4 copper. Purse B has 4 silver and 3 copper. If a coin is pulled at random from one of the 2 purses, what's the probability that it is a silver coin? Basically, I'm looking for a silver coin, right? So silver from the purse A times purse A silver from the purse A and silver from the purse B, excuse me. Okay, so please check again, same condition of total probability. So we have PSA will be how much, bacha? Silver from the purse A will be, please check, 2 by 6. And choosing the purse A, sir, there are 2 purses, no, so we have half chances, so 1 by 2. Okay, great. And same way, silver from the purse B will have 4 by 7. We'll have 4 by 7 over here. And choosing the purse will be again half of chance. There are 2 purses, so half of chance is there. So have a look. What I'm getting here is, so I can take this. Please check. I have over here 2 and 2 is cancelled, right? LCM of, okay, this I can also cancel. 2 2s are 4. So LCM of 6 and 7 will be 42. We have 6 7s are, so 7 I have over here. 7 6s are, so 6 2s are 12. We have 19 by 42 as the answer. Simplify from your side if you're not sure. Okay, I'm cancelling this 2 and 2 and 2 to 4. Then LCM is of 7 and 6 is going to be 42. 6 7s are, so 1 7s are is 7. 7 6s are, so 2 6s are is 12. 19 by 42 option is C. Again example on total probability. Okay, total probability question. This is done. 14th is done, sir. 15th now. 1/2% of the population has a particular disease. Some disease it has. For the entire population, how many percent is there, bacha? 1/2%. What it means? 0.5 is the value? No, it's a percent. 0.5% has the disease. Okay, chaliye. A test is developed for the disease. The test gives false positive of 3%. What it means is, basically somebody who doesn't have a disease, even though they don't have disease, the test result come out as positive. That's called as false positive. Okay, so 3% of chances are there that even though you don't have a disease, you might get positive out of the test. Okay, so that's 3%. And false negative, it means even though I have a disease, somebody has a disease, okay, and the result is negative, that's called as false negative. Okay, chaliye. So what is the probability that a random person, Amit, tests positive. Okay, so I'll call, let's say, a person who's affected with disease, with the event D, and again D dash will be not affected, sir, not affected with the disease. I hope you get it. So D dash is the event where the person chosen at random is not affected. D is for affected. Okay, so please check. So if I have to write this as what I'm looking for, probably that a person Amit is testing positive. Okay, let's call this event T to be test outcome as positive. Test outcome is positive. Okay, so I can test positive even though I have a disease or don't have a disease. When I have a disease means, please check, I have the, so test is positive when I have the disease. That's how you write it, correct? Now test is positive, I have the disease and test is positive. That's how you write it. And second case, test is positive when I don't have the disease. Please check, correct? Now I've taken one extra bracket, I'll just remove that. 1 second. Yeah, so I can, any person can test positive from two categories, whether he or she has a disease or doesn't have a disease. Okay, so affected by the disease or does not affected by the disease. Please check. So test positive when disease is there, test positive when disease is not there. Please check. So chances of him testing positive when disease is there, please check. So all right, we have a case which of 2% negative, right? Negative outcome, even though, so what is the chances of accuracy over here? 98%, right? Please check. He has a disease, okay, and for him to get the right test outcome, what chances are there? Chances are only 98%, because 2% is false negative. False negative means somebody has a disease and the outcome is negative. That's false negative. Okay, so basically I'll have 0.98 as the test outcome coming out as positive when he has a disease. Okay, and what the person to have a disease will be 0.5%. No, so I'll get this as 0.005. Please check. What is this given as, sir? Affected category. No, so PD is given here 0.5%. It means 0.005 is the value. Clear? Next I have same way PD dash, PTD dash. Okay, so for this we'll have please check, we have false positive as 3%. Okay, so we'll write that now. We are looking for only positive, right? So 0.03 into PD dash, how much that will be? 0.995. If PD is, sir, 0.05%, for the person to not have disease will be, sir, 99.5%. Now, and what is that is given as 0.995. Multiply and check the result. We'll have 8 5s are 44, and we have please check 9 5s are again 45 plus 4 is 8 5s are 40, carries 4. 9 5s are 45 plus 4 will be 49, carries 4. We have 9 5s are, yeah, that's it. Correct, now. So we have 3 plus 2 5, so 0.00, right? Correct. Yeah. So next we'll multiply these two. 5 3s are 15 we have over here. 9 3s are 27. 128 carries 2. 27 230. We have 0.03085 because we have 2 plus 3 5 decimal places over here. Now if you add them, we have both 0.5 decimal places only, no? So we'll have 5 over here. 9 plus 8 is 7, and we have 4 plus 1 is 5. We have 3. We have 0.0357. Okay, basically I can write this as 0.035 is enough. 0.035 is enough. Option will be, sir, B. Please check. Option B is correct. Okay, for the test outcome to be coming out as positive even though the person has disease or not, this is the result, 0.035. okay, basically 3.5%. no, 3.5%. Moving on to question number 16 now. Okay, I hope you have seen the problem. Please check. Yeah, 16 now. A bag contains 3 white and 6 black balls, while another bag contains, okay, bag A has 3 white and we have 6 black balls, and bag B has, please check, this is bag B. Okay, bag B has 6 whites and 3 black balls. Okay, 3 black balls. 6 whites and 3 black balls. A bag is selected at random and a ball is drawn. Okay, same condition. Looking for the black ball, okay? So black ball from the bag A. Please check. And black ball from the bag B. Okay, if you want I can write this as B dash actually, just to make a difference. So write this as B dash. Okay, black ball from the bag B. Okay, chali. So black ball from the bag A, sir, will be 6 by 9. And PA, sir, how much? Choosing one bag will be 1 by 2 only, no? Plus. Black ball from bag will be 3 by 9. Choosing bag will remain same, 1 by 2. Please check. We have 3 2 is 6. 3 3 is 9. 2 and 2 is cancelled. 3 3 is 9. I get here as 1 by 3 plus 1 by 6. LCM is 6. 3 2s are. Please check. 3 2 is 6. And of course we have 1. Answer is 3 by 6. Answer is 1 by 2. Answer is 1 by 2. Option D is correct. Option D is correct. 16 option D is correct. This is 1 by 2, sir. Okay, chali. 17th now. 17th question now. What it says, given 3 identical boxes, box 1, 2, 3, each containing 2 coins. Okay, so let's call this to be box A, box B, and box C. So each containing 2 coins. Box 1, both coins are gold. So we have first box as GG, and second box is, what is it? Both silver, so SS, and the last is 1 gold, 1 silver, so GS, sorry, 1 gold and silver, so GS. Okay. Now question is, a person chooses a box at random. So basically, if you want to choose the box, so PA equals to PB equals to PC will be equal to 1 by 3. 1/3 of the chance of picking any of the boxes, 1 or 2 or 3. Okay. And if the coin is gold, what is the probability that other coin is also gold? Okay. So we are looking for first coin is gold, sir, and second also you want gold. From the first bag only it is possible, because in the second bag there is no gold. In the third bag you have only 1 gold. The first one is gold, second one can be gold only if they have chosen actually bag A or box number 1. Okay, so this can be equal to, please check, P. I'm going to apply the Bayes theorem now. So P gold from the box A or bag A times chances of picking me bag A. Okay, and again we'll write total probability. Please check here, PGA into PA plus, can I write PBA into PB? Don't have to write that, but I'll show you why we don't have to write that. So we write here PGB into PB plus P gold from the box C or bag 3 and PC. Why not second one? Because is there a gold in the second box, bacha? There is no gold over here. This will become 0 then, na? This will become 0 over here. Please check. Gold from box A. I can pick gold in any way possible, no? Both chances are there going to be there. 2 by 2. So 1. Because both of them are gold, no? So what is the chances of getting gold from the box A? 1 by, so basically 2 by 2, right? So 1. And the probability of picking the box B or bag B is 1 by 3 divided by, same value will come over here, PGA PA 1 by 3. This is going to be 0, sir, because picking a gold from the second box is not possible. Both are silver. And the last one, please check, we'll have picking the gold from the this box. We have 1 gold, 1 silver means half a chance. Okay, and picking the box or bags 3 will be 1 by 3 chance again. Right here 1 by 3. So what I'm getting, please check, I'm getting this value of P AG as, have a look, numerator is 1 by 3, denominator is bacha 1 by 3 plus 1 by 2 into 3. Cancel this 3 and 3. How can you do that, sir? Take common and cancel. Alright, so I have the value as 1 upon, please check, 1 plus 1 by 2. So it will become 2 plus 1 is 3. So 1 upon 3 by 2 goes up, 2 by 3 is the answer. Please check. This is clear. This is clear. Question number 17 is done. 18th now. a bag contains n plus 1 coins. It is given that among n plus 1 coin has head on both sides. So biased, head on both sides means biased, right? Okay. Rest coin are usual, means one head one tail. Okay, the coin is randomly selected and gets thrown. Okay, if the probability of getting head is 7 by 12, probability of getting head. Okay, let's take the event first of all. So event A, if I choose the both side head coin, that is like choosing both head coin, both side head coin, that's event A. And event B bacha going to be normal coin, okay. So please check. So if I choose, if I try to get head from the both side head coin, answer is 100% because both side is head. If you toss it, you get head only 100%. And if you get head from the normal coin, will be sir 1 by 2. Because head and tail both is there, no? Chances half and half. So you have chances of getting head from the coin which is having both side as head, will get that value as, I hope this is clear, okay? If not, I'll write it again. 1 second. Yeah. Both side, event A is representing both side is having head. Both side is head. Okay, this is the normal coin. Okay, chaliye. So if you look at this now, so choosing a head, getting head from the first event category will be 100% chance, and head from the second normal coin will be 1 by 2 chance. That is okay. So I can get head in both the way possible. What is that? Head from the, please check, both side head coin, okay, and plus head from the normal coin. Okay, now how many coins are there, bacha? What is this answer? PHA is nothing but 1, so write this as 1. What is PA value? We have only one coin out of n plus 1. Think about it. We have only one coin which is having both sides as head, means 1 out of total coins n plus 1. Over here PHB is sir 1 by 2, right here 1 by 2, and number of coins is what, bacha? So only one is different type of coin. Normal is going to be n, so n upon n plus 1, n upon n plus 1. Take LCM now. So I have LCM as 2 times of n plus 1, and I get this will become 2 plus n. What I have over here is 7 by 12. 7 by 12. Please check. If you compare, okay, n is sir 5. How come? Please check. 5 plus 1 is 6. 6 into 2 is 12. Okay, and from here 5 plus 2 is 7. So n is 5. Please check. 5 plus 1 is 6. 6 into 2 is 12, and 5 plus 2 is 7. So n value is 5. Option C is correct. Option C is correct. Question number 18 is done now. Question number 19. I hope this is clear, right? Yeah. 19 now. Have a look. A person has undertaken a construction job. Okay. The probabilities are 0.65 that there will be a strike. Okay, and 0.80 that the construction job will be completed on time if there is no strike. All right. First of all, probability of strike bacha is 0.65. Probability of no strike will be 0.35. Let's get this data at least useful right now. Chance of strike is 0.65 or 65%. Chance of no strike is 35%. Okay, 0.35. Now 0.80 is the probability when job will be completed if there is no strike. Okay, means basically they have given here job is completed when there is no strike. Is given as 0.8. Okay, and the job is completed even though there is a strike is 0.32, right? Okay, job completed when what is there? Strike is there. What we have? 0.32. 32% is the chance over there. Okay, so I'll write it again. Your J represents the job will be completed on time. J represents event. J represents job completed on time. Completed on time. Okay, so we're looking for what's a okay, determine the probability that construction job will be completed. Basically PJ they are asking, right? Total probability one more time, PJ they are asking. So both the cases will write. For case when the strike is there, so we'll write here PJS into PS plus PJS dash into PS dash, correct? So we have 0.32 into, what is it there, 0.65, okay, and for this we have, so please check, for this part we have 0.8 and PS dash will be, sir, how much? Please check. 0.35, 0.35, okay. Cancel over here. I get 100 on this side, so I get 4. Please check. 520 is 100, right? And it becomes a 0.13. 513 is 65, so 0.13. Okay, have a look. And cancel this with 2 tens are there, and for this I get 216. Okay, so I'm getting here 16 into 0.13. Basically, I can write this as 16 into 0.013, because there's a 0 over here, no? 10 is there, so I write here 0.013 plus other part as it is 0.8 into 0.35. Let's calculate on this side. So I get PJ equals to, please check, 16 to 3. So we get this as 48 carries 4, 20. We have 0.208, okay, and we have 3 decimal places. So 0.208. All right. What about this, sir? 8 into 35. So for this we have 5 8s are 40, carries 4. 8 3s are 24 plus 4 is 8, carries again 2. Okay, 2 only, 280, right? This time 280. Please check. Decimal places will be again 3, bacha. We have 1, 2 and 3. All right. So we have one more time 3. Add it. 1 second. Add it. We have 8 plus 0 as 8, and 8 plus 0 one more time 8, and this is 4. Correct now? 8 plus 0 is 8. Correct. 0.488 is the answer. Yeah. Option A looks good. Option A looks good. 19th is option A. Done. Please have a look. It's a good question. Again, a case of total probability. Let's move on to next question now. So question number 20. Achha, before I move on to that, I have to ask all of you to join Abhyas KCET test series if you're somebody looking to prepare for your KCET 2025 examination, to solve variety of questions, okay, across the chapters, across subjects, PC, MB. You're getting total of 35 tests, okay, including part test and full length test, priced at 1498. 1498 is the price actually. So this is including the success blueprint test series, but that is already over. The boards are over, so your price will be 1498 for your Abhyas KCET test series. Okay, it's very useful. Again, if you are looking to solve multiple questions, lot of questions, okay, this is the way to do it. Okay, so again, one more thing, if you are somebody who is looking for Comet K, so yes, we are coming here with your Comet K crash course. In that you'll get 12 mock test, complete syllabus coverage till 11th of all 11th and 12th, 5-year previous year question papers, and you'll get live doubt solving sessions, class notes, and recorded revision videos. Okay, so all of that will be there in the Comet K crash course, and the offer price is going at 1,999. If you are looking to purchase right now, the link will be again provided to you. One more thing you can do is you can call on this number to enroll in either of the courses. Okay, but again, for both the courses, for the Abhyas KCET test series or Comet K crash course, the link will be given in the video description. Please go ahead and check it out right now and enroll right away. It's very important for your syllabus and for your preparation. You don't have much time left. This is the way to do it. Go ahead, join right now. Let's move on to question number 20. So we have A and B are two events such that P of A is non-zero. Of course, PBA we are looking to find. Okay, there are two conditions given, condition 1, condition 2. Let's apply both of them. So first of all, we'll write the formula for PBA. We have PB intersection A upon PA, right? Now we'll use the case 1. What is the case 1, sir? Case 1 is A subset of B. Okay, it means basically PBA will become equal to, sir, PA. Correct now? A is subset of B, sir. Basically like this. Please check. B is over here, right? A is inside. So A is a subset of B. Of course, in that case, what will happen? The intersection will be, sir, A only, right? So we'll have PA for that case. So this will become, please check, you'll have this condition PBA as PA upon PA. Hence answer is 1. Hence answer is 1. So we have two options like this, A and D. Let's look for the second part. What is the second part going to be? Okay, this is clear. A intersection B is null. Okay, it means probability will also be 0. Probability of that will be 0, sir. Probability of intersection of A and B will be 0. In that case, this numerator will be 0, sir. Okay, so we'll have the answer as option D. Please check. We'll have the answer as option D. For this part it's 1, for this part it is 0, right? So you'll have PBA as 0 by something, that is PA, doesn't matter because it's in the numerator is 0, hence will become 0. Option D is correct. 21 now. Chaliye. So question number 21, if PA intersection B is 7 by 10, PB is also given, where P stands for probability, of course, then PAB is how much? Okay, let's find this out. Again, we have the formula for conditional probability as PAB equals to PA intersection with B upon PB. I have both the values, right? Yeah. So write this over here, 7 by 10 divided by 17 by 10, clearly, 20, right? 20, yeah. 10 2 times 2 will get over here, 2 will come in the numerator, you'll have 7 into 2 by 17, hence 14 by 17, option C is correct. Option C is correct. Please check. 21 option C is correct. It's a question from 2016. Question number 22 now. If A and B are two events such of a sample space such that PA is given, PB is given, they're looking to find this value. This is given, they're looking to find this value. Please check. So I can write this as PA dash P or conditional probability with B is equal to, please check, PA intersection with B upon PB, right? Okay. Alright, let me change something. Actually, I'm looking for this condition, right? PA dash B. So we'll have PA dash B over here, of course. Yeah, so PA dash B will be equal to PA dash intersection with B upon PB. Okay, and now how can I write this? So this will become, please check, it will become from here 1 minus PA intersection B upon PB right? Have a look. Is it right? No, it will be, sir, no, sorry, it will be not 1, it will be PB actually. This will be, sir, PB actually. Okay, I'll show you that in the Venn diagram, don't worry. It will be, sir, PB actually. How can I say that? Have a look in the Venn diagram. So if I have two events, A as over here, B over here, please check. Now I'll show you the meaning of the intersection over there. So I'm looking for intersection of B with not A. B with not A. So this B with not A is basically this. Correct now? This is the intersection of B with not A. Sorry, intersection I'm looking for, right? So only this, only B part. B with not A is only B part. Outside was actually not, that was the condition of not A. B with, intersection of B with not A is not only but only B part. Okay, that is I can write as total of PB, this becomes total PB minus intersection of A and B. Basically, I'm going to remove this part over here. If I remove this part over here from the total B, I'll get the only B part, right? That's what I've done. From the total B, I've removed the intersection part. I get only B part. This is only B part, right? It means only B. I hope you get it. So from the total B, I remove the intersection part. I get only B. Okay. Now if you check over here, I get 1 minus PA intersection B divided by PB, okay, which will give me the value as 1 minus, this value will become what, bacha? Will become PA dash B, correct? PA conditional probability with B. We have the value 0.5, please check. So I have 1 minus 0.5. Answer will be 0.5, basically, how much is that? 1 by 2. Basically, how much? 1 by 2. So option B is correct. I hope you can see that. Okay. This clear how I got this with the help of Venn diagram. 22 is done. Moving on now. 23. If A and B are two events such that PA is 1 by 3, PB is 1 by 2. Okay, they're looking for similar conditions. So they're looking for PA dash with B. We'll write same thing again. PA dash intersection with B upon PB. Okay. So I'll have one more time. Please check. I'll have this as PB minus PA intersection B. I just did the same thing over here and divide by PB. Please check. I have the values now. I have all the values. PB I have as 1 by 2. Okay, I don't have to do that actually. So I don't have to do this part. I can just divide it, no? Yeah. I'll substitute later. So if you do the next step, you'll have 1 minus PAB intersection with B and upon PB. We have the values now. Please check. I have 1 minus, this value is nothing but 1 by 6. So right here, 1 by 6 divided by PB is nothing but 1 by 2. PB is 1 by 2. Cancel it. 2 3 are 6. So I get 1 minus 1 by 3. Answer is 2 by 3, right? 2 by 3 is the answer. 1 minus 1 by 3 is 2 by 3. Please check. I hope this is clear, right? If not, I'll write again. Not a problem. Not a problem. We'll write it again, sir. 2 by 3. Answer is 2 by 3. Option D is correct. Correct? Option D is okay. Previous one I wrote the option right. Yeah. B is correct. 23 is done. 24 now. Events E1 and E2 are given like this. Okay. Form a partition of the sample space S. All right. Is any event such that PE1 and PE2 are both half and half. Okay. And PE2A is given as 1 by 2. All right. They're looking for PE1A. PE1A. I have to use the Bayes theorem over here. That's a very good question. Please check. So I'll go from this side. Okay, they've given PE2A also. Please check. This is your clue how to use Bayes theorem because we have AE2 and E2A both available over here. How you write PE2A? Remember, we write this as PA E2 times PE2, right? Correct, huh? Divide by total probability. We'll have the same thing over here. PA E2 times PE2 plus what I have? PA E1 times PE1. Am I right? That's how you're gonna write this value. Please check. I have PA E2 now. So that value is given here. 2 by 3 times PA E2 will be 1 by 2. So write that 1 by 2 over here divided by. Have a look. Same thing will come on this side. The same thing. 2 by 3, 1 by 2 plus PAE1. That is not there. No, PAE1 is not there. That's a variable. I'll give it as a variable X. Okay. And PE1 is again 1 by 2. And they've given this value PE2A. They've given that as 1 by 2. Now is my calculations. Please check. So first of all, 1 by 2 is cancelled over here. Correct, huh? Why not with this, sir? We don't have to. We are going to take this 1 by 2 common. That will cancel this 1 by 2 in the numerator. Okay, we can't cancel with this one. Okay, chaliye. So what I get now? I am getting here 2 by 3 upon, please check, 2 by 3 plus x. This is equals to 1 by 2. Am I right? Okay, I'm going to do the cross multiplication. Okay, so I'll have, bacha, I'll have this in this form. Please check. I write this as 1 by 2. The LHS as it is equals to, I write here 2 and then bring this 3 in the denominator. I'll get 3 over here. Okay, and this will be again like this 2 plus what I have 3x divided by 3. I've taken the LCM over here, so I get 2 plus 3x by 3. This 3 and this 3 will be cancelled. Okay, now it's simpler to calculate. Please check. So I'll have 1 by 2 cross multiply now. So I get 2 plus 3x equals to 4, right? 2 plus 3x into 1 is 2 plus 3x, 2 into 2 is 4. I'm looking at the value of the 3x, so we'll write 3x equals to 4 minus 2, which is nothing but 2. Actually, we get x value as 2 by 3. Sorry, 2 by 3. Visible now? 2 by 3 is visible? Okay. So please check. This is clear. So much is clear. This value x is given. What is the value of x, bacha? This is x is nothing but, please check, I have taken for PAE1. This is your PAE1. Okay, this is your x value, but I'm looking for PE1A. Again, I have to use one more time Bayes theorem. PE1A will be, sir, PAE1 times same thing PE1 divided by same thing. I'll have PAE1 times of PE1. Okay, plus I have in the case of when event occurred with the event E2. Okay, for the event E2, we'll write here PA E2 with PE2 We have all the values. Let's use it now. So I'll get this value. Please check. Calculation I'll do now. Last step, bacha. So I have PA-E1 now 2 by 3. So write this value 2 by 3. Okay. I have this PE1 as 1 by 2. So write this value 1 by 2 divided by, same thing over here, 2 by 3, 1 by 2 plus PAE2. I have that as 2 by 3 one more time. Please check. And 1 by 2. If you look carefully, sir, actually, if I call this value 2 by 3 into 1 by 2 as x, I have x upon x plus x. Or if I take this value, let's say, this whole thing as p, I'll have p upon p plus p, basically p upon 2p. What is the answer going to be? 1 by 2. Answer will be 1 by 2. Yes or no? Okay. If you want, you can actually see this out. This will cancel, sir. This will cancel, sir. What I have left now, check this out. So I have this condition is nothing but PAE1, right? So PAE1 is nothing but, have a look, I have 1 in the numerator and I have 1 over here, 1 over there. So 1 plus 1. Answer is 1 by 2. So either you can see from here only, this is the same thing, right? This, if this is value is P, this also is P, this also is P, right? So P upon 2P will be 1 by 2. Option is D. It's a very simple but good question, okay? If you think a little bit, okay? If you think a little bit, okay? Because you can see here they have given PE2A and AE2. Of course, then we have to use the condition of Bayes theorem to help our cause, okay? 24th is done, 25th now. Given that A and B are two events such that, okay, PB is 3 by 5, PAB is 1 by 2. Okay, we've been given a union also. We're looking for PA, right? Okay. Chaliye. Right from here, we'll have this as intersection of A with B divided by PB. I have all the values. PB is 3 by 5, so we'll write here. This also is given 1 by 2 equals to PA intersection with B upon what I have. Please check. This is given as, PB is given as 3 by 5. Okay. If I cross multiply, I'll get this as 1 by 2 into 3 by 5 equals to PA intersection P. Okay. Chaliye, so we get here 3 by 10, right? 3 by 10 is my PA intersection B. One part is clear. This part is clear, right? Not a problem at all. This is 3, sir. This is 3. Okay. Great. I'm looking for P. Okay, A. So right here, A union B is given as, we know this value, PA plus PB minus P of intersection of AB. Okay. So we have A and B given as 4 by 5. So right here 4 by 5. This is unknown. So right here PA as it is. This will be PB as 3 by 5 minus 3 by 10, right? Okay. So I get what, bacha? I can bring this on this side. Both of it. I'll have 4 by 5 minus 3 by 5 plus 3 by 10 as PA. Please check. I'm moving both of these on this side. Okay. I have minus 3 by 5 and plus 3 by 10. LCM will be, sir, 10 only. I have here 5 2s, so 4 2s is 8. 5 2s, so minus 6 and plus 3. I get 8 minus 6 is what, sir? 11 minus 5. So 5 by 10, right? So 1 by, I'm getting this value. Please check here. 8 plus 3 is 11 minus 6 is 5. So 5 by 10, basically 1 by 2. Basically 1 by 2 is the answer. Option B is correct. Have a look. Option B is correct. This is clear. 25th is done. Question number 26 now. Okay. A car manufacturing factory has two plants, X and Y. Plant X manufactures 70% of the cars. Okay. And Y manufactures 30% of the cars. 80% of the cars at plant X and 90% of the cars at plant Y are rated standard quality. Okay. And a car is chosen at random. It is found to be standard quality. Okay. So we have got a car which is standard quality. They're asking that probably that it is coming from the plant X. Okay. They're asking this value, right? Okay. Chaliye. Now understand this very carefully. S represents the chosen car. Chosen car is of standard quality. That's your the variable S represents, okay, the event, and X represents, of course, what represents the plant X, from the plant X. Okay. So if I'm looking for PX, If I choose any car coming from the plant X will be, the chances of, if I choose any car, the chances for it to be coming from the plant X will be what, sir? 0.7. And for similarly for the any car is chosen, chances of it coming from the plant Y would be 0.3 because they're manufacturing 30% of the car, right? So 0.3, okay. And now they have also given 80% of the cars from plant X is standard quality, okay. So they have given here standard from the plant X is 0.8 and standard from the plant Y is 0.9, right? Please check. So standard is from the plant X is that 80 and 90% is from the plant Y as standard, okay. I'm going to apply now the Bayes theorem, please check. So I'll have X now, I'll write again, not a problem. I'll write for PXS. I'll apply the Bayes theorem for this. PXS when given by PSX times PX upon, same thing will repeat in the total probability, PX plus standard from the plant Y, okay. Answer, please check what I have over here is 0.8 times what I have, PX has 0.7 now, so 0.7 upon what I'm getting over here, same thing, 0.8 into 0.7 plus 0.9 into 0.3, 0.9 into 0.3 over here, 0.9 and 0.3, okay. So let's simplify, I get 0.56, over here also I get 0.56, over here I get 27, right? Yeah, so 0.27, add it, I'm getting here 0.56 upon 7 plus 6 is 3, 5 plus 2 is 7 and 1 8, okay. 0.83 decimal is cancelled. Answer is 56/83. Option C is correct. Option C is correct. Please have a look, okay. Have a look. It's a good question, asked in 2021. Have a look. Done. 27 now. If A and B are two events such that PA is 1 by 2, PB is 1 by 3 and PAB is 1 by 4, okay. Very good question, sir. Excellent problem based upon the set okay. How can we solve it? We're looking for this condition, right? If we know this property, right, PA transpose, so basically A complement with B complement intersection is nothing but 1 minus, okay, yeah, I'll write this first. So we can write this as, have a look, PA union B transpose, I'll have this value as 1 minus PA union B. So if I can find our value of P and B, value of PA union B, then my job is done, okay. So let's look for the condition. I have PA, I have PB, I'm missing only intersection, so let's do that. Okay, get from here, please check. A dash P equals to 1 by 4. This is PA intersection B upon PB equals to 1 by 4. I have this value, have a look, PB is given as 1 by 3, right? So I have PA intersection B as PB into 1 by 4 means 1 by 3 into 1 by 4, it means 1 by 12, okay. Now I can find this union value. PA union B is equals to PA plus PB minus PA intersection B, correct? We have the values now. PA is nothing but 1 by 2 plus 1 by 3 minus 1 by 12. Please check. 1 by 2, 1 by 3 minus 1 by 12. I'm getting this value of union of A and B probability is nothing but LCM is going to be 12, so we'll have LCM as 12 over here. 2 6 are, so we have 6 over here, and 3 4 are, so we have plus 4 over here minus 1. I get 9 by 12, basically 3 by 4. So my union value is coming as, please check, 3 by 4. I'm going to use this and this only, please check. I'm looking for this condition, right? Probability of A complement with B complement intersection will be nothing but 1 minus PA union B. Have a look. So I can write this as, please check, 1 minus 3 by 4. Answer will be 1 by 4. Option A is correct. Option A is correct. Have a look. Excellent question. Excellent question. Okay, if you know this property from the set theory, your question is very simple. If you don't know this property, you can never solve this question. Okay, it'll be very difficult and challenging to do this. Okay, if you apply base theorem and other thing, if you know this property, then everything is very simple. Okay, so 27 is done. That's why I keep telling you guys, sets is important, relation and function is important, because it finds use in the other chapters. Okay, 27 is done. 28th now. So 28th now. A pandemic has been spreading all over the world. The probabilities are 0.7 that there will be a lockdown. Okay, 0.8 that the pandemic is controlled in 1 month. Okay, if there is a lockdown, and 0.3 that it is controlled in 1 month if there is no lockdown. Of course, it will be difficult, no, to control if there is no lockdown. Okay, the probability that pandemic will be controlled. Okay, so it's a question of, bacha, please check here. It's a question of total probability. What we write in the denominator of the base theorem, that one, that is the question on. Okay, so we're looking for, let's say I'll write the event over here. So chances of lockdown. So L represents, I'll write the event's name first to help our work, become more effective. So I'll write this L as, please check, chances or basically probability of lockdown. Okay, that's your L represents lockdown chances. Okay, and what else we have? Yeah, so of course we'll have L dash as chances of no lockdown. Complement will be no lockdown. Okay, opposite case, I'm taking this as L dash. Okay, and other thing is C I'll take. Okay, I'll take the event C as controlled in a month. Controlled in a month. Okay, now what about looking for? I'm looking for, please check very carefully, I'm looking for PC na probability that pandemic will be controlled in a month. Okay, so PC is my event. Now it can happen in two ways. Okay, controlled if there is a lockdown, and controlled if there is, please check, no lockdown. So I have to use the conditional probability over here to define my total probability. I have to use conditional probability to define my total probability. Okay, chances of the controlling in 1 month if there is no lockdown. Please check. Please check. Okay, so have a look. They have given these values to us. Controlling if there is a lockdown. Control if there is a lockdown. They have given here, bacha. Control if there is a lockdown. 0.8 that controlled if it is a lockdown. So this value will be 0.8. PL is how much, sir? Chances of lockdown is 0.7. Please check. Okay, if you are not sure, see here. They have given PL value as 0.7. So PL dash will become 1 minus 0.7. How much is that? 0.3. I'm going to use it over here. That's why I'm writing that. And chances of controlling in 1 month if there is no lockdown is 0.3. Control in 1 month if no lockdown. Please check here. No lockdown. Okay. So 0.3 I'll write for that. And PL dash is how much, sir? One more time, 0.3. What I get? Have a look. 8 7s are 56. So 0.56. And I have 0.09. Correct now? Added, I get 6 9 is 5. So 0.65 is my answer for controlling in a month. Okay, 0.65. Option A is correct. It's an excellent question. Okay, we like it from 2022. Moving on to question number 29 now. Okay. So if A and B are events such that PA is 1 by 4, PAB is 1 by 2, PBA is 2 by 3, then PB is how much? Okay, check here. So we are looking for PB, right? If I can find the intersection from there, I have PA right with us. I can find the intersection from there and use it in this case. Simple question. Okay, please check. So I'll have PBA equals to 2 by 3, right? Write this. PB intersection A upon PA equal to 2 by 3, right? I have the PA value 1 by 4, so write it over here. PB intersection A upon 1 by 4 equals to 2 by 3. Multiply this on the side. You'll have PB intersection A equals to 2 by 3 into 1 by 4. How much is that? 1 by 6, right? Yeah. Correct? I'll cancel this 2 and 4, right? 2 by 3 into 1 by 4. It's in division over here. It'll become multiplication. So it will become 1 by 6. I have the intersection value now. So I'll use the second one. we have PB, okay, sorry, PAB, right? Now we have to use PAB. Okay, chali. So we have to use PAB equals to PA intersection with B upon PB, right? Okay, so we have this value as how much? I'm going to find this value, right? So right here, PB equals to PA intersection B upon PA conjunction with B. This is same as this, okay? PB intersection A is same as A intersection B, okay? So we get 1 by 6 over there. And we have this value also given 1 by 2. What I get? 2 3 are 6 means 1 by 3 is the value for PB. 1 by 3 is the value for PB. Option D is correct. Please check. Option D is correct. Simple question. Simplest of all. Okay. Chali. Just you have to apply the 2 times condensation probability of PBA and PAB. Okay. Done. 30th now. This is not a P by Q. Excuse me. If 3 events of a sample space are E, F and G. Okay, this is a definition based question, sir. How we write this? Remember, PE intersection with F intersection with G is nothing but going to be, we can write this as PE with PFE, right? PFE, okay, and we'll write it one more time. G is also there, yeah. G, E, F, correct now, or FE, correct? E when F has already occurred and G when both has occurred. What it means, sir? Intersection of E with F with G means E when F is occurred and, sorry, correct, no? Yeah. And we'll have this case, yes, G when E and F both has occurred, okay? E when F has occurred, like that. Please check. So we'll have this value done now, correct? So option PE, FE, G intersection with E and F, okay? Yeah, and we can write this value, no? Remember, this as EF also, right? It means both options are correct actually. Please check here. Both options are same only, okay? Hence, correct answer is option C actually, sorry. Correct answer is option C. Both of them are correct, right? So option C is the right option, which is both A and B. Please check. I can write this intersection of E and F with as simply EF. Simply EF. They are exactly same. PE, PFE, okay, PG, EF, right? Writing this as EF. Answer will be option C. Okay. So this completes your top 30 from the chapter LPP and probability. So your PU2, one more session will be coming on vectors. So we'll do that part and your PU2 will be over and moving on to PU1. Okay. So please practice more and more questions. I was getting a lot of questions in the live sessions also. So is this enough, sir? But yeah, what I'm doing over here, no, I'm taking the most probable questions from your PYQs. You can see the trend, because if you solve the PYQs, you can see the trend of the questions. Okay, so what are questions they are asking, what concepts have been repeated. Okay, I'm giving you year wise also which year what question has been asked. So you can see a lot of questions are coming in. If you talk about probability, questions are coming in the concept, a lot of questions are coming in the concept probability category. Okay, so you have to remember that it's a very important chapter. Questions on the independent events also very important to you. Again, base theorem can be asked once or twice. Okay, so remember this is the trend. Once you know this, you can solve a similar question from your side. Where you can solve it, again you can join our Abhyas KCET test series to solve more questions, because 35 tests in PCMB, so many questions are there going to be there in part test and full length test. That will again give you more confidence going into the examination of KCET 2025. Again, if you have other source that you want to solve from, any textbook you're referring, any other question bank you're referring, anything else you're referring, you can solve the questions based on the trend of the PYQs. That's why I'm giving you the PYQs. And of course, there are some questions which is not a PYQ, which I feel can be expected in this year as well. Okay, that's why the questions are like this. These 30 questions are not enough, but they are very good problems. If you solve it, you have the idea what type of questions is asked. Of course, you have to solve more questions, but this is at least 30 you have to solve. Okay, so please solve this questions without fail. All right, so pause the videos and try from your side. Get the sessions PDF available to you in the WhatsApp channel and solve the questions again and again. If you're comfortable solving all the questions, then yes, you are. You can say that you're prepared. Okay, you have solved the question throughout the year, right? If you solve these questions now, and if you're comfortable solving all the questions, then you can say you're prepared. So with this, I'm going to end the session today. Just keep working hard, keep smiling. Take care. Bye-bye.